Hello, dear students. Myself Arif Khan Pathan, Senior Lecturer, MC Society Institute of Pharmacy, Diploma, as in campus, Camp Pune. Now we have to see the third part of the heterocyclic system. In this, we'll see the fused ring heterocyclic ring containing their number as well as the nomenclature is complicated one. We had seen in previous part the numbering of the simple heterocyclic ring. Now we are moving toward the numbering of the fused heterocyclic ring containing one heteroatom or more than one heteroatom. In this case, we are taking the example that is the quinoline for a fused ring structure. So wherever there is a fused ring structure, so there will be two types of name, trial name as well as the systematic name. Trial name example, quinoline is a trial name. Normally here onward we will use the trial name itself, and systematic name will be the in different way. Systematic name will be given in different way. We'll see the example that is quinoline. Quinoline is a fused ring structure of the benzene plus pyridine. Now as far as the say numbering is concerned to the pyridine, we have to start numbering with the nitrogen. If we are giving the numbering by this way 2 3 4 5 6, so we can correlate that the benzene ring is fused with the pyridine at 2 3 position. At 2 3 position the benzene will get fused to form the resultant fused ring structure is called as quinoline. And now the numbering, the way of numbering will be in this way. We have to start the numbering with the nitrogen, and we have to cover first the heterocyclic ring completely, the numbering to heterocyclic ring, then have to cover the homocyclic ring, because in this type of fusion there are two rings fused together. This is the homocyclic ring, that we call benzene, and pyridine is the heterocyclic ring. So we are giving numbering to heterocyclic ring either clockwise or anti-clockwise way. There is no problem, that will be by the rule. But when this pyridine or this heterocyclic ring fused with the homocyclic ring to form fused ring structure, then we must have to, there is a restriction that we must have to give the numbering to the heterocyclic ring first, then the homocyclic ring. Okay, so that, and there is a say we are giving numbering to these common carbon atoms at the last. Say after 4 we are not giving numbering to this carbon because this is the common carbon atom, this is again a common carbon atom, so we are skipping common carbon atoms and direct skip to the next, that is 5th position on the homocyclic ring. So this is the this we had seen that how the fusion is going on, and what is the trial name for fused ring structure. This fused ring structure is quinoline. Whereas if you are talking about the systematic name, the systematic name is this one, benzene fused at 2 3 position of pyridine heterocycle, and hence it is chemically it will be 2 3 benzopyridine or benzo B pyridine. B stand for what are the position we had taken, that is 2 and 3. If we are giving the name to the site, so this is the site A, this is site B, this is site C, D, in this way. So either we can give the numbering or we can give the name to this particular site. So as far numbering is concerned, benzene fused to pyridine at 2 3 position, like in same way, in case we are giving the name to the sites, then it will be fused at B site. Benzene fused to pyridine at B site, that's why name will be the benzo B pyridine. And 2 3 benzopyridine, because 2 3 benzo is attached to at the 2 3 position of pyridine, that's why 2 3 benzopyridine. So in this way the systematic name can be given, but don't get confused. Normally we are using the, for these heterocyclic ring structures we are using trial name. Always we will refer as quinoline. This ring always we refer as a quinoline. We will not refer it as 2 3 benzopyridine or like benzo B pyridine. So this systematic name we will not use. We'll use normally the trial name. Next, so this we have seen the first example of the fused ring structure in which the numbering is given, that is quinoline. Now in certain fused ring system the numbering is not started with heteroatom. Like in previous one we had started numbering with the nitrogen because nitrogen was heteroatom, though it was a fused ring structure. So next example we are going to see in which we are not starting a numbering from heteroatom. This is the structure, this is the heterocyclic ring, which is again a fused ring. And in these, the way of giving a numbering, you can see that there is a say second position is getting by nitrogen. We are not, it means that first position is not getting by nitrogen, or we are not giving first to the nitrogen or counted as a 1 to the nitrogen, and we are starting with these carbon and say that nitrogen is at the second position. And this is the way of numbering to these ring, and this we are calling a isoquinoline. Now, what is the difference between quinoline and isoquinoline? Simply one can say that in quinoline the nitrogen is at one position, in isoquinoline nitrogen is at second position. Okay, and again the basic difference is that we had seen that the benzene fused with pyridine, in case of quinidine it will be 2-3 position, between the 2-3 position, whereas in case of isoquinoline the benzene will get fused with pyridine at 3-4 position, not at 2-3 position, it will be at 3-4 position, so that the ring will get change its configuration, or the spatial arrangement will get changes, and hence the ring become isoquinoline. So this is again the one of the exceptional case where which the numbering is not being starting with the heteroatom. Next example that we are going to see, that is acridine, where the nitrogen atom getting 10th position. This is the 3 ring fused together that we call acridine, in which we can say that the pyridine is sandwiched between 2 benzene ring. Pyridine, this middle ring is pyridine, is sandwiched between 2 benzene ring. And this is the way of numbering. We have to start numbering either of the benzene ring, either of the homocyclic ring, and like for example 1 2 3 4, we have to skip this nitrogen, then directly go to the next homocyclic ring, 5 6 7 8, and then 9 and 10. In this case we can say that we are not starting the numbering from heteroatom, even we are not covering first the heterocyclic ring, numbering to the heterocyclic ring. It is an exceptional case in which we are starting with the homocyclic ring. In previous, when we had seen the example, that is quinoline, we had started a numbering with nitrogen. The rule was followed. Next, we had covered with the numbering proceeding to the heterocyclic ring first, then we are shifted on homocyclic. Now in this case the reverse, or it is will be exactly opposite, the rule is not being followed, and that we call exceptional cases, acridine. So in this case we are starting with the homocyclic instead of heterocyclic, and we are skipping the completely the heterocyclic ring, or heterocyclic ring the numbering is given at the last. So we are skipping directly on next homocyclic ring, 5 6 7 8 9 10, and the nitrogen getting 10 position. So this is again another example, acridine, which again doesn't follow the rule, or these are the exceptional cases. Next, phenothiazine, where which there are 2 heteroatoms, one is sulfur, second one is a nitrogen. So phenothiazine, you can see that S5 and 10, this scheme is being followed the same, like we are starting with a homocyclic, either of the homocyclic ring, it's again a sandwich ring, or sandwich structure. We can say that 2 benzene ring fuse, 2 benzene ring sandwich is the middle ring. So we are starting with either of the homocyclic ring, and same we are counting sulfur, then 6 7 8 9 10, and 10 is actually common in both acridine as well as in phenothiazine, but both are the exceptional cases of numbering. That is, we had already cleared that these all are the fused ring structure, and in a fused ring structure the numbering is complicated. We must have to remember the sequence and the pattern of way of numbering to these exceptional cases as well as the other heterocyclic ring, other fused heterocyclic ring, because in simple heterocyclic ring the numbering is simple, the rules are simple, and mostly all to be followed by the simple heterocyclic ring, that is the single heterocyclic ring. But if you are talking about the fused ring, there is a say somewhat complications, and that is why we already cleared in first line that the numbering will be the complicated one of fused ring structure. Now next example we are going to see, that is purine. In certain fused ring system, the heteroatom is not bearing the least possible number. There is no relationship of the rule. Exactly, it is being expelling the rule. or it being breaking the rule, and we are calling much of exceptional cases, that is purine. Now purine is a fused ring structure in which if we are going to analyze this structure, then this is the say 6-member ring, 2 nitrogens are there, and the relative position of nitrogen will be 1 and 3, whereas this is again 5-member ring having 2 nitrogen, and the relative position of nitrogen will be 1 and 3. So as far as the naming, this is a pyrimidine, this ring is called as imidazole. Pyrimidine, imidazole. So as we know that previous example quinoline was the fused ring structure of benzene plus pyridine. Now this is the purine, which is a fused ring structure. So two rings, we can say that the pyrimidine fused with the imidazole to form the resultant structure that we call a purine. Okay, and in this case actually we are going to start with numbering with this nitrogen 6-member ring. We are covering first 1 2 3 4. Now we are in this case we are counting a common carbon atoms also. This and this are the wherever there is a joint, wherever there is a joint between these two or fusion of these two rings are called as common carbons. Like so in this case we are counting common carbon also, means we are completely covering 1 2 3 4 5 6, completely 6-member ring we are first covering, and then we are shifting on the next 7 position. Will go to the next nitrogen of the next 5-member ring, 7 8 9 in this case. So this is an much of the exceptional case in which we are starting numbering with the nitrogen, then we are covering for we are counting the common carbon atoms also. And again, instead of like for example if we had not shifted like 4 or 5 next to this nitrogen, we gone completely for first 6-member ring, 5 6 we have covered 6-member ring first, and then we shifted to the next 5-member ring, which was again the part of exception. So dear student, this is a purine, which is again exceptional case, and you don't worry, we will take it as exceptional, no problem. And always the numbering pattern wherever the purine ring comes or heterocyclic ring purine comes across, so always will give you in the same way. The numbering will be always in the same way, that we have to start with nitrogen of 6-member ring, then we have to cover completely 6, then we got shifted to the 5-member ring, and numbering proceeding from 7 8 9 like this. Next, that is the part nomenclature. Nomenclature in this: name of 5-member heterocyclic ring containing 2 double bond ends with OLE. Now the before that we had seen the numbering, how the numbering will be given, either a simple ring or to the fused ring structure. Now that was part only just about the numbering. There was rule about only about the numbering. Now in this part we are going to shift to the naming that we call nomenclature. How the names will be derived of these heterocyclic ring. Numbering is a different part, naming is a different part. So if there is a say normally the 5-member rings are there, which has a heteroatom, and there are 2 double bonds, so normally the suffix is that OLE. For example, we are going to see that this is a pyrrole, and it is being ending with OLE, means normally OLE is there, it indicates that it's a 5-member ring. By the rule it's a 5-member ring, and will have the 2 double bonds, and PYR stand for it's a nitrogen. PYR, aza, azo, if these types of terms will come as a prefix, it indicates there is a nitrogen, and suffix OLE indicate the 5-member ring 2 double bond. Like name of the 5-member heterocyclic ring containing 2 double bonds ends with OLE. Next example we are going to see, in which the 5-member ring is there, 2 double bonds are there, the condition is being satisfied for first rule. So normally the name of this ring will be ends with OLE. So this is the imidazole. Again we can see that OLE is the suffix, means it's a 5-member ring and 2 double bond. Remaining things will be as a part of suffix, like there are 2 heteroatoms, both are nitrogen, so it will be imidazole. Imidazole stand for 1 2 3. There are 2 nitrogen, relative position of nitrogen is 1 and 3, And as for the, it's a simple heterocyclic ring. Why we are giving nitrogen, this nitrogen as a 1? Because it is a saturated nitrogen. And as per the rule, if the simple heterocyclic ring having one nitrogen, so having two nitrogens, so amongst these, the position 1 or preference for position 1 will be given to the saturated nitrogen. So this is saturated, this is unsaturated. So normally we will start numbering with these. That's why 1, 2, 3, 4, 5. Relative position of these nitrogens are 1 and 3. And this is imidazole. Next, if, second rule of giving naming, if only one double bond, then E of OLE is being replaced with INE. Means, if the 5-membered ring, and instead of two double bond, if there only a one double bond, then what will be there? This OLE, in this, from this OLE, E got replaced with INE. E of OLE is replaced with INE. We'll see. This is the example. We can compare this ring and this ring. Mostly the relative position is same, 1 and 3 nitrogens, 1 and 3 nitrogen. So this is the 5-membered ring having two double bonds, so it got ended with OLE, and this is the 5-membered ring with only one double bond. So what will be there? E is being replaced with INE. So it become imidazoline. So imidazole 1,3 position, 1,3 position. If there will be two double bonds, so it become imidazole, but only one double bond, E is being replaced with INE, it become imidazoline. So we had written 4 imidazoline because the position of double bond, again we have to specify, that is between 4 and 5. Wherever there is a double bond between two positions, the previous position is taken as the representation or suffix of its position. Position of double bond will be 4 and 5, so we are writing 4 imidazoline. Next example again, this is again the example in which two nitrogen 5-membered ring, it's a imidazole, or we can say that this ring is derived from imidazole, but the changes are there. Instead of two double bond, there will be one double bond, and we have to give a numbering. As for these, there are two nitrogens, one is saturated, second one is unsaturated, so obviously we have to start numbering with a saturated nitrogen, single bonded nitrogen, 1, 2, 3. Now we can see that one double bond, so now imidazole got replaced with imidazoline. Prefix with, before that we have to specify the position of double bond also. Now in this ring, the position of double bond is 2 and 3. So basically we can write it's a 2 imidazoline, sorry, it's a 3 imidazoline.